Have you ever really thought about it? Where's our power going to come from when the fossil fuels start to run dry? It's one of the biggest questions of our time, right? Well, in this explainer, we're going to dive deep into the amazing science behind the top contenders for our energy future.
And really, that's the central question, isn't it? We're not just talking about, keeping the lights on at home. We're talking about powering everything. Our industries, our tech, the sprawling cities of the future.
Okay, so before we jump into all the cool solutions, we've got to get a handle on just how big this problem is. Because our global appetite for energy, it's not just huge, it's growing like crazy.
So just how fast are we talking? Well, let's take a major global economy like India, for example. Since just the year 2000, its energy consumption has more than doubled. Think about that for a second. That's a massive, massive increase. And it's all driven by a growing population and super fast industrialization.
All right, so where's all this power actually coming from? This chart, wow, it really lays it all out. More than 80% of it comes from just three things: coal, oil, and solid biomass. And that right there, that heavy, heavy reliance on the old ways, that's exactly why we need to find some powerful, clean alternatives, and fast.
Okay, so let's get into the good stuff, the solutions. And we're going to start with the two heavyweights, the absolute giants of the renewable world, the sun and the wind.
First up, solar. Now, what's really important to get is that there are basically two main paths to capture its energy. You've got solar thermal, which uses the sun's heat. Just think of a massive magnifying glass boiling water. And then you have photovoltaic, we usually just call it PV, which does something that is frankly kind of magical. It turns the sun's light directly into electricity.
And this is what solar thermal looks like on a truly epic scale. It's called concentrating solar power. Just picture this, a huge field covered in mirrors. They're called heliostats, and they all move, tracking the sun across the sky. They focus all that sunlight onto one single spot on a central tower. This heats up a fluid inside to, get this, over 500 degrees Celsius. And that intense heat creates steam, which then spins a turbine.
Okay, so what about photovoltaics? This is the tech in those solar panels you see on rooftops. A PV cell is basically a slice of a special semiconductor material. When sunlight, the photons, hits it, it literally knocks electrons loose. And that flow of electrons, that's an electric current. It's amazing. No moving parts, no steam, nothing. Just silent, clean power made straight from light.
All right, let's switch gears to wind power. And I gotta tell you, there's a piece of physics here that is just absolutely mind-bending. The amount of power you can get from the wind, it's not just proportional to its speed. No, it's proportional to the cube of its speed. So what does that actually mean? It means if the wind speed doubles, you don't get twice the power, you get 8 times the power. Isn't that wild?
But physics always has a few rules. There's a catch. You can't actually capture all of the energy in the wind. I mean, think about it. If you did, the air would just stop right behind the turbine, and then no new wind could get through. So nature has this kind of built-in speed limit, and it's called the bed's limit.
And yeah, that limit has a very specific number attached to it, 59.3%. That's it. It's a hard and fast rule of physics. Doesn't matter how brilliant our engineers get, you can never, ever capture more than that slice of the wind's energy. It's just a fascinating, fundamental constraint of the universe.
So how do we get close to that limit? Well, turbines work in one of two ways. You've got the old-school drag-based designs, where the wind just pushes the blades. Think of wind in a sail. Simple. But all the modern turbines you see, they're lift-based. Their blades are shaped just like airplane wings. They create a difference in air pressure that generates lift, which spins them way, way faster and a whole lot more efficiently.
So sun and wind are obviously the big ones, but they are not the only players in the game, not by a long shot. There are these other amazing sources of power kind of hidden all around us, in the oceans, deep inside the earth, and believe it or not, even in our trash.
So let me ask you a question. Do you think you could power a city using just the temperature of the ocean? It sounds like something out of a sci-fi novel, right? But the answer is, yeah, you totally can. That temperature gap between the warm surface water and the freezing cold depths is a gigantic, basically untapped energy source.
The tech has a name, Ocean Thermal Energy Conversion, or OTEC for short. And the way it works is brilliant. It's like a giant heat engine. It uses the warm surface water to boil a liquid that has a really low boiling point, something like ammonia. The vapor from that boiling liquid spins a turbine.
Then it pumps up frigid water from the deep ocean to cool that vapor, turning it back into a liquid so the whole cycle can start over again. It's pretty genius.
Okay, from the ocean depths, let's go deep underground. Geothermal energy. This is all about tapping into the incredible, non-stop heat that's just radiating from the Earth's core. And the huge advantage here, unlike solar or wind, this power source is always on, 24 hours a day, 7 days a week.
So how do we actually use it? Well, one really clever method is called a binary cycle plant. Binary just means two. You use this when the hot water you pump up from the ground isn't quite hot enough to make steam on its own. So instead, you use that hot water to boil a second liquid, one with a way lower boiling point. The vapor from that liquid is what spins the turbine. It's a great workaround.
And last but not least, let's talk about biomass. This is basically getting energy from any kind of organic stuff. We're talking wood, crops, even the stuff you throw in the garbage. I mean, it's probably the oldest energy source humans have ever used, right? But now we're finding some really clever, modern ways to harness it.
A really important process here is called anaerobic digestion. It sounds complicated, but it's not. You just take a bunch of organic waste, stick it in a big sealed tank with no oxygen, and let bacteria go to town. As those little microbes break down the waste, they release a gas that we can capture and use as fuel. It's basically hijacking nature's own recycling process.
So what exactly is in this biogas? Well, it's mostly methane. And guess what? Methane is the main ingredient in natural gas, the stuff we drill for. So the incredible thing here is that we're essentially making a renewable version of natural gas from garbage. Instead of drilling deep into the earth, we're just using our own waste.
Wow. Okay, so we've looked at a whole arsenal of technologies, right? From the sun and wind to the heat of the ocean and the earth. Which brings us to the big picture, the really crucial final part of this conversation.
When you lay all these options out side by side, one thing becomes crystal clear. There's no magic one-size-fits-all solution here. There's no single silver bullet. Solar PV is quiet and you can put it almost anywhere. But geothermal gives you that 24/7 reliability. Wind packs a huge punch, and biomass, it turns our trash into treasure. The future isn't about picking a winner. It's about building a diverse toolkit of solutions that work together.
But let's be real for a second. At the end of the day, all this incredible science, all this amazing tech, it doesn't mean a thing if the power isn't affordable and reliable for regular people. This whole transition, it's not just an engineering puzzle. It's a massive economic and social challenge too.
And so that leaves us with the big question. We have the technologies. The potential is absolutely enormous. The real challenge now is figuring out the right recipe, the right mix of sun, wind, earth, and life to power a truly sustainable world. So I'll leave you with this. What do you think our energy mix is actually going to look like in 2050?